আমরা আজকে ঢাকা লিড ফেস্ট এখানে এসেছি। আমাদের সাথে আছেন ডিন সারা গিলবার্ট। উনি অ্যাস্ট্রাজেনেকা ভ্যাকসিনটা ওনার হাতে ডেভেলপ হয়েছে এবং সেটা নিয়ে আজকে এখানে আলাপচারিতা করছি ওনার সঙ্গে। Big thank you and congratulations on developing the most affordable vaccine in record time that got almost 1/3 of the population out of this pandemic. And now also sharing your story through your book Vaxxers, the inside story of the Oxford AstraZeneca vaccine and the race against virus. So my first question to you. You read about 4 people in China having developed a strange pneumonia. And within 2 weeks, you along with your team designed a vaccine against a new pathogen. What triggered this response way before the pandemic was even declared?
Well, we've been working towards this and thinking about it for some years. So I've been working in vaccine development. I've done quite a lot of work on influenza vaccine development, and we know that influenza is always going to cause another pandemic at some point in the future. We can't predict when, but there will be more influenza infections with different strains of influenza viruses that we don't yet have vaccines for. So I've been thinking about the challenges of that, and then moved on with the Ebola outbreak in West Africa in 2014. That really changed the way people started to think about outbreaks of infectious diseases, because there are a lot of viruses, such as the Ebola virus, that we know about, and we know they will periodically cause outbreaks, and we don't have any vaccines. And we could have vaccines against these viruses, and we could have them stockpiled and tested and ready to use, so that the next time there's an outbreak, we do have a vaccine to use. And so I started work on developing vaccines against a number of different viruses. And the only way to do that, really, without taking a very long time and spending a very large amount of money, is to use what we call a platform technology. So that's a way of making a vaccine that we can adapt to make vaccines against lots of different pathogens, in this case different viruses. And the platform technology that we were working on in Oxford is adenovirus vectored vaccines.
Yes.
Other vaccine companies also use adenovirus vectored vaccines. And we decided to work with adenovirus vectored vaccines because we felt it was a technology that was suitable for use on a large scale. So we'd already assessed the technology. We knew that we could use it to develop a new vaccine relatively quickly, that it would be possible to manufacture in large quantities, and that it would not be too expensive to manufacture. So all of that had been thought about in advance. And we'd also started to think about how could we go really quickly if there's an outbreak of a new virus that we haven't seen before. Hadn't really done very much work on that, but we had at least started to think along those lines. And then when the virus that caused those infections in the first 4 people was eventually shown to be a coronavirus, that was quite easy for us to respond to, because my team had been working on a vaccine against MERS, which is Middle East Respiratory Syndrome, which is also a coronavirus. And although we'd only done a couple of fairly small clinical trials, we'd seen that the vaccine was giving the type of immune response that we would expect to be protective. And so the design that we'd chosen for that vaccine was likely to be successful, so we could adapt that, start again, make a vaccine against a new coronavirus, and get off the ground very, very quickly.
Fantastic. So you successfully developed the universal flu vaccine, and that stimulates T-cell mediated immunity.
Well, we're still working on the universal flu vaccine, though we still have some way to go with that.
Yeah. And your vaccine development work for MERS and Nipah are also well known, as we just mentioned. So do you necessarily think about what particular immunity you are looking at, like the T-cell mediated immunity or the humoral the antibody-driven immunity?
Yeah.
Do you particularly look at what would trigger what, or is it just like you have the platform already? You insert that gene into the adenovirus that's the recombinant technique that you use. So for this one, the AstraZeneca, I mean, does it induce more T-cell or antibody?
We know that this type of vaccine will induce both antibody and T-cell responses. And what we've learnt over the years working on different vaccines for different diseases is that if we take the complete coding sequence, the genetic instructions for the whole of the protein that we want to raise the immune response against, and express that we put that gene into the adenovirus, what happens is that protein is made inside the cells in our body after vaccination in exactly the same way that it would be if we had an infection with that particular virus. So the conformation of the protein is correct, and we don't have to change it very much. We just put a little extra sequence at the beginning of it, which means that we make more of that protein, but we don't change the protein in any other way. And that means that we get the right conformation, and that means that our immune system sees something that looks like the virus that we're trying to protect against. If we start cutting it up and using a bit from here and a bit from there, then the conformation won't be correct. And although we might get an immune response, it might not be the right immune response. So what's worked for us is to use the protein exactly as it is in the virus, because that means we get the right type of immune response.
And why is it advised for people having been infected recently with COVID to wait 3 months before taking a booster shot? Booster shot. And also, why is AstraZeneca, why did not they pursue the FDA approval?
So on the second question, why didn't they pursue the FDA approval? That's really a question to ask AstraZeneca. So not me as the academic, and that was a company decision. I do think they felt it wasn't needed because obviously the vaccine's been licensed in the majority of countries in the world.
2.5 billion already been distributed.
Yep. And it's not likely to be used in the US. They're using the RNA vaccines, so it doesn't really make much difference. But whether the decision was a company decision, and I didn't play any part in that. Sorry, the first question again.
The first question is, why do we have to wait 3 months?
Oh yeah, so
if I get infected now, I have to wait another. That's what they say.
Yeah,
I have to wait
so
3 months.
Getting infected after vaccination is also like having a booster. And it will improve your immune response. And so you don't need another vaccine for at least 3 months. And what we showed in the clinical trials of the vaccine is that leaving a longer gap between the vaccinations,
especially with AstraZeneca, yes.
Well, but also with the RNA vaccines,
right.
You get a better immune response after the second dose if you leave a 3-month gap rather than a 1-month gap. So thinking along the same lines, you don't need to have your booster vaccination until 3 months after if you have a COVID infection.
Cover a wider set of population, right?
Particularly in the beginning of the vaccination campaign, it was really important. So if we can give everybody the first dose, what we saw was we got very rapid onset of protection that will last at least 3 months, probably longer, until you get the second dose. And that does mean that more people can receive their first dose, and that protects the whole community much better.
So now China. Despite a 3-year lockdown, they have not developed herd immunity. They have so far, from what I have read, they have like 8 vaccines already approved, homegrown. None of them are any messenger RNA vaccines. So at this point, like any other expert, you being the expert, would you think that they actually need a different sort of vaccine to provide immunity?
There is one company in China that's producing an adenovector vaccine.
Okay.
So that it will be very similar in its effects to the Oxford AstraZeneca vaccine. It's just one company though, so I don't know what the production capacity is and whether they can produce enough to immunise everybody. We have seen in other countries that received the Chinese vaccines early on in the pandemic that although the efficacy was lower than some of the other vaccines,
it worked.
It did work, and that those people then benefited from a single dose of one of either the RNA vaccines or the adenovector vaccines, and that then greatly increased the protection that they got from those vaccines. So it is possible to give people who've had 2 doses of an inactivated viral vaccine, which is mainly what's been used in China, a boost with a different technology and see very good results. I think that will be the best thing to do at this point.
So did you have an opportunity to do any sort of work with find more about the Sinopharm Sinovac that was widely used? What's your take?
So personally, I haven't worked on those vaccines, but reading the scientific literature, we can see that the immune response that you get after using those vaccines is lower, and the efficacy is also lower. If that's the only vaccine that's available, definitely worth using that vaccine. But if other vaccines are available with higher efficacy, then it would be preferable to use those.
So the new variant that has evolved in China again and already exported even to Bangladesh, we got 4 cases and we did the genome sequencing from those people, the samples, and it did show a different variant. Do you think it might cause a new outbreak, or is it, and for particularly like for, if I talk about Bangladesh's context, 51% population are already, they have gotten their third booster, the first booster is the third dose, and a large population is also, they're also getting the fourth shot. So is it going to, do you think it's going to cause another, like, should we expect any more outbreaks, or?
I don't expect it.
Yeah, it's more transmissible but less virulent,
yeah.
Right? So.
I don't expect it to cause major difficulties. What we've seen is that with each dose of the vaccine, people's immune response increases, but it also broadens, because we don't get an immune response that only works against the original virus that the vaccine was derived from. It's broader than that. And all of those, what we call subdominant immune responses, the ones that are not the strongest ones, but they all increase when people get their second and their third and then their fourth dose. And that's what gives us much better breadth of protection against different variants. So I think it still looks very promising for using the original vaccines.
Great, great. And this question I have heard from before. I was also given a task by our DGH's people to find is, do you think, is there evidence that men are more vulnerable or more susceptible to COVID than women? And is it related to, because maybe women have more immune genes? And
so I think early on it did look as though there was probably greater susceptibility in men. As we've gathered more data, I don't think that's really been borne out.
Okay. So you produced a vaccine that is cheaper, and because of that, it was the vaccine of choice for the low and the low middle income countries, including Bangladesh. And it's probably the second most widely used vaccine after Pfizer.
Mm-hmm.
And with the new variants coming along, I mean, Pfizer and Moderna, they have developed the bivalent vaccines now. So they are using like a combination of more strains in their vaccine. I think you just answered the question out there. Is AstraZeneca, do you plan to do that as well, like add more strains to your already developed?
So again, that's a decision for AstraZeneca. We did work with them starting at the end of 2020. We worked on setting up a system so that we could change the vaccine, introduce a new sequence, and then quickly get that one into manufacturing. We did a clinical trial with one of them. But there isn't any good evidence that the changed sequences and the bivalent vaccines are actually more effective than the original vaccines. And remember that we can only make a vaccine against the sequence that we know now, and it will take several months to get the vaccine manufactured and then widely used, by which point that won't be the major variant that's circulating anymore. There's something else. So I think AstraZeneca have decided that they're probably not going to go down the bivalent route, still seeing very good protection from the original vaccine.
Perfect. And it's been used mostly on people over 18. So do you plan to make any changes to make it more suitable for children aged 5 and above? And because it's a very stable vaccine, it's very easy to store. So it will be very hard. It's going to be easier to reach places. So do you think you have any?
Yeah, the fact that it doesn't need to be stored frozen is one of the reasons that we prioritise this technology, because that's a really good feature. If you're going to use it in countries that have a high temperature most of the time, it helps if you don't have to have frozen storage of the vaccine, and that helps reduce the costs and makes it much more accessible. There were trials done in children with lower doses. It's possible to use the vaccine in children. It's up to the policy makers in each country to decide, based on the data that there is and based on the situation in that country, whether they would like to use it in children or not.
What are the other diseases you're working on? I mean, being a vaccine developer, is there a preferred technology that you use? You just spoke about a platform that you normally use. So you are using the recombinant, you use the adenovirus, and do you have like any other techniques that you're more familiar with, or you like using, or is it more like fun-driven?
So the vaccines I'm working on at the moment for Nipah virus, very important in Bangladesh, Middle East respiratory syndrome, and Lassa fever virus, which cases occur in Africa, they all use the same adenovirus vectored vaccine. So the same approach. I have worked on another viral vectored vaccine called modified vaccinia virus ankara. It's related to the smallpox vaccine. That one is not so suitable for manufacturing in very large quantities.
Right.
So it's not our preference if we need to make large amounts of a vaccine, and also it's very good at boosting immune responses. It's not so good at giving strong immune responses from the first dose, and for an outbreak we really need to be getting strong responses from the first dose. So the adenovector still works very well for all of those. What I would really like to do is to get back to some more basic research and continue to develop more vaccine technologies. I don't think we've reached the end of the road. It doesn't have to stop with RNA vaccines, adenovectored vaccines, inactivated vaccines. I think there's probably more that we can do, and I'd be really interested to be able to spend some time thinking about better ways of making vaccines.
So that is like the scientist in
Yes.
you, and the other factor that you develop something, you are an expert at scaling up. Like you manufacture, you develop something in the lab, and you scale it up to GMP for mass production. So that's also another concern that you always look into when you're developing a vaccine.
Absolutely, yes. I mean, there wouldn't be any point in developing a vaccine that works really well in a very small clinical trial, but is not suitable for large-scale manufacture, or it would be extremely expensive to manufacture at a large scale. So I always tell my students that whatever part of vaccinology you work in, you really need to understand the whole process from concept through the initial manufacture, testing, licensure.
Pragmatic.
So if you only concentrate on the technology, you might develop a technology that has no practical use because it can't be manufactured at scale.
So now this question is on the perspective of Bangladesh more. So dengue is an epidemic in Bangladesh, and I myself am very scared of it because my son had it and it was not a very good reaction. And due to the climate change, the weather patterns are changing. We are having late rains, and the epidemic usually would happen right after the rainy season or right as it began, and it would start waning in October. But this year we saw a different pattern, and we saw the large number of cases and deaths from dengue in October and November. So do you see yourself like developing something against all the 4 serotypes of dengue virus? I know it's a different kind of virus, because in many parts of the world it's an epidemic.
Yeah, so personally I'm not working on a dengue virus vaccine. I do have former colleagues who are, and are working on one that would work against all 4 serotypes.
Right.
So that's something that I hope to see developed in the future.
Do you forecast more pandemics in the near future due to the climate change and deforestation and all that's happening now?
Well, we definitely will see more pandemics. There will always, whatever we do, there will always be pandemics. But I think what's increased the likelihood of them happening with greater frequency is the fact that many viruses exist in wild animals.
Yes.
And if they start to infect humans, the majority of them will do nothing, but a very small percentage of them are capable of infecting people and then spreading and causing an outbreak.
Bats and
Yeah, there are a lot of viruses in bats in particular. But also other wild animals that we don't necessarily come into contact. But with deforestation, greater urbanization, there's more contact between humans and wild animals that may be infected with different viruses that we haven't encountered before. So it increases the chances that more viruses are going to jump the species barrier and start causing infections in people.
So this is a question mostly, I think, for AstraZeneca and not you. I mean, they have manufacturing sites in various countries.
Yeah, I think 26.
26 countries, right. And is there a possibility to have something in Bangladesh? I mean, we have 170 million people, and our pharmaceutical industry is quite enriched, that covers 95% of our local needs. And since it did work, the vaccine did work, and AstraZeneca is known, you as well, being a scientist, you work at manufacturing something that's more cost effective. So do you see them looking into Bangladesh as a new frontier?
Well, I don't know what AstraZeneca will do, but within the university I'm interested in supporting more manufacturers. I think we learnt a lot in the pandemic, and one thing that we learnt is that vaccine manufacturing technology can be transferred to multiple different sites who can all then work to manufacture the same vaccine, and there are now many vaccine manufacturers as a result of this that have the technology. None as yet, as you say, in Bangladesh. But what I'm interested in doing is working with different countries to see which vaccines those countries really need,
Right.
and then looking to see if through collaboration with scientists and with companies in those countries, it might be possible to develop those vaccines without necessarily needing the involvement of a European or a US big pharma partner. This is obviously a very long-term aim. It's not something that can be achieved quickly, but I think that a lot of the things we learned in the pandemic support the idea that it would be possible to develop vaccines that regions need, and for them to develop those vaccines themselves.
Fantastic. And I read somewhere that you like gardening to keep calm.
Mm-hmm. Yes.
And you are at a Lit Fest now.
Yes.
Do you have time, or can you make time to read fiction? Any particular genre, writers that excite you?
I do read as well to relax. I haven't been reading anything very challenging recently. I haven't needed to be intellectually challenged in my relaxation reading, so I've been reading a lot of detective fiction purely just to kind of, it's escapism. It
Right.
helps me
Mind
switch
off.
off, and so nothing very literary, I must say. In the past, I've really enjoyed the writing of Hilary Mantel, and I've read some of Amitabh Ghosh's work as well. He has a book called The Calcutta Chromosome, which I read when I was working on malaria, so that was relevant to what I was doing. I hope in the future to have more time for reading and to think a bit more about what I'm reading.
You're an inspiration to women, as we saw. In the whole auditorium was packed with young generation women, and you are a mother of 2 daughters. I know you have triplets. You're a mother of 2 daughters. And any advice to Bangladeshi youth population, particularly the young women?
Well, I think, as I said in the auditorium, it's really what you should do is find out what interests you,
Right.
and what you like to do, and to study that. Don't think about something that you think you should be doing, or a field that you should be getting into. What really interests you in the subjects that you study in school, start to follow your own interest and develop that, and then think about that, where that will take you.